Hello folks, and welcome to what will hopefully be the first of a short series of videos that I'm going to be doing here on the, I guess more generally, CCS fast charging, and in particular using the BMW i3 LIM module to achieve that. Two things I want to cover before we start in on the very technical side of things. But I suppose even before I cover those two things, I should warn you that this video is going to be long. It's going to be boring. The first part of it is probably going to be really boring because it'll be just me talking. And then the second part, the highlight, will be some flashing LEDs here. So I can't emphasize enough that if that doesn't sound like your cup of tea, go up to the old search box there, enter funny cat video, and you will be taken away from this disaster. So, it's just my standard, I guess, public health warning. If, however, you wish to hang around, then I welcome you. First topic, I'll just cover very quickly, and I'm going to be doing this probably on most videos for the next while. And that's simply to remind folks at the video, if you're watching this on YouTube now, it's also, you can find the same version free of advertising on Vimeo. So just to be aware of that, YouTube's latest policy changes means that they will be putting advertisements even into videos that are not part of their advertising program, as I am not. So just a friendly reminder there. So before we hit the technical side here, of the LIM and the CCS stuff, I want to just address, it's kind of one question, but it's been asked in a couple of different ways across different platforms over the last, I guess, week or two that I've been posting on social media about my work on this particular project. And it comes down to folks basically asking me why I'm bothering to reverse engineer the i3 LIM, or indeed any other module from a OEM car maker that handles the CCS and the charging in more general terms, versus just building one from scratch, because CCS is of course an open standard. Now, I'm not going to go too deep into that. There is, I guess there's a bit of politics involved in that, and I just do not touch that on this channel at all. However, from a technical point of view, CCS is not just about replicating the communication protocol, which is a bit of a handful in itself, as we will soon see. But it's about all of the other elements that go along with it, such as detecting when we're on a CCS versus an standard AC charging system. Controlling the DC contactors as required by both the CCS standard and by the commands from the charging station. Monitoring the voltage on the charging station side of the contactors prior to closing them. Whole lot of little things that you don't immediately think of when you just, think it's just talking, it's just a communication protocol. So the i3 LIM is a very neat module for us here, because it encompasses nearly everything that we need to have a kind of a dreaded phrase, plug and play solution to CCS fast charging. Now, there are documents that one can get out there. There's even some example code floating around in the depths of the web. But what there is not out there is a proven working design, or even an alpha version of such a thing. While I'm confident that there are indeed versions being developed, in-house closed shop type of things, there's nothing really out there for mere humans such as ourselves that we can see how certain, I guess, certain obstacles and challenges along the way were met. Whereas with the LIM, well, we know that it works because you can CCS fast charge a BMW i3. So that's the element of using something that's well proven, has got all of the kind of design know-how of my favorite automaker in there. Just to, I guess, address the situation as well, because there are some commercial CCS solutions available now. I know Zero EV published a video recently where they have CCS on one of their Porsches, I believe. And I think there is another one. Oh, I can never think of the company's name. Advantix in Switzerland, I think, have a commercial CCS box that you can just buy, and it does all of this stuff for you. But as usual here, we're more into the open source and the sharing of knowledge. So what I have been looking at has been trying to find, number one, a OEM vehicle module that will do this for us. And number two then, which has been the real challenge, has been to obtain the necessary CAN logs from a parent vehicle while it is undergoing various charging regimes. Now the LIM, I purchased my first LIM, I'm going to say it was the end of last year, so the end of 2020. I know quite a few folks on the Open Inverter forum purchased them in or about that time. It was Mike, actually, on the forum there that I think posted about this in November the first time and drew my attention to it. That would be Mike from the YouTube channel Mike's Electric Stuff, which is a really good channel, by the way. If you haven't heard of that, do a search and subscribe to him, because he does some really fun stuff on there. Well, okay, that's fun for me, so probably not for the funny cat people, but okay. So yeah, Mike posted about that back in November, and this thing, I've got one here for you. I'll give you close-ups and stuff soon, but this thing basically just at first glance looked to be perfect because it does everything that we spoke about. It's got the Qualcomm modem in there for doing the GreenFi communication over CCS. It's got all the stuff in there to handle the normal AC charging. It's got a driving circuits in there for the connector locking and for the fast charging contactors. So pretty much the ideal solution. So like I said, I grabbed one towards the end of last year, 2020. And since then, it has been a real tour de force to get a log from a BMW i3 powertrain CAN during AC and DC and various charging regimes. I had a lot of folks come out to assist me with that, particularly in recent weeks. So want to take this opportunity to thank them. But just what day is today? Is Thursday, I think the 27th of May. I'm going to say it was Monday. It was just Monday gone that I started to get logs. One from a gentleman in Russia and another from one of my Patreon supporters in the United States. And pretty much it was basically I've been head down into the CAN logs and here working on the bench for the last few days. And just this morning now, got the CAN to a point that it basically handles AC charging here absolutely fine, which we will demonstrate to you. And we can take the DC side of it right up to the point where it would be expecting to see the GreenFi communication appear on the control pilot line. Obviously, that's not something that I can generate here, so it just basically falls out at that point. So, I have two LIMs here. One from a 2014 vehicle, which is on the bench, and one from a 2017, which is just behind us. The 2017 module will be installed within the next couple of days in the Grey Goose, which is our E46 Touring conversion, because that actually has the CCS socket in there, and I've wired up the high voltage contactor box for that also. So with a bit of luck, the next video we will have some results for you from an attempt at CCS fast charging with the LIM in the E46 Touring. Under no circumstances do I expect this to work the first, second, or even the 10th time. Those of you that have been with me for the long haul know that back in 2015, when EVTV and Colin Kidder and a whole bunch of us were working on the CHAdeMO side of things, I was driving the E39 in and out of my local CHAdeMO station for, I'm going to say, probably a week before we had the first successful charge. The good news from myself from a CCS point of view is that we may about maybe 6 or 7 miles up the road there is a Ionity fast charging point with, I think it's either 5 or 6 250 kilowatt CCS charging points there. So we will be test firing on those guys, as I say. I'm going to say probably in about a week's time. So last bit of background then before we tear into the technical side is why CCS? Why not just stick with the CHAdeMO? Well, for me, the attraction of it is that it lets me use a single socket on the vehicle. Most of us doing conversions put the charging socket in the fuel filler. So we just take out the fuel filler and put the charging socket in there. And unfortunately then, if we want to do CHAdeMO, it means putting another charging socket in the vehicle. So that's why you'll see me on the E31. I've got my kind of fast charging exhaust pipe on there with the CHAdeMO socket in it. But on the E46 Touring, I didn't do that. I got myself a CCS socket, put that where the fuel filler was, and so that has the potential to give me both AC and DC fast charging in a single socket. The second attraction is the higher power that's available from CCS charging points. I believe up to 250 kilowatts at the Ionity stations, but I think that requires some of the crazy high voltage batteries to get up there, like 800 volts or stuff like that, because I think they're 250 amps. But that's still twice the power, still 100 kilowatts of fast charging versus the 50 that we get from CHAdeMO. And additionally, not so much here in this country as in the US and other parts of the world, there are more CCS charging stations available than there are CHAdeMO. Now, the good news in Ireland is that most of the fast chargers that have been installed by either by private companies or by the national electricity provider have got multi-standard, so they do CHAdeMO, CCS, or the 43 kilowatt AC. But those going in by the likes of Ionity and so forth are just CCS only. So, I don't think CHAdeMO is dead personally. I think that is a much used phrase. I think the amount of people that just, I guess these days, need to make clickbait YouTube videos about something like Tesla is dead or Tesla killer or all of this nonsense. So I think the CHAdeMO is dead crew are kind of, probably on a similar vein. So, folks, that's it. I've prattled on enough. I hope this has explained a little bit more about why I'm looking at using OEM components for my CCS solution. Final word on this, by the way, Johannes is working on a more direct approach. There's this QCA 7000 Qualcomm module that you can get from AliExpress now. I've ordered one just so I can look cool, but Johannes has ordered one, and he's actually probably going to do something with it. Now, the good news about the LIM is that it uses the same QCA 7000 chip. So assuming that I get all this up and running, I will log the SPI comms that go on between the microcontroller and the QCA 7000 chip in the LIM during a fast charging session. So we should be able to give Johannes a bit of a boost with that, assuming again that I get all of this working. So that's enough about me talking. Let's get to some doing. Okay, so firstly, apologies for the mess on the bench. I know it is pretty crazy. So this black box here is our LIM. This is my 2014 one. And this one is my 2017. And we see here that there's our date code. It is not without some sense of irony that I seem to be reverse engineering something made by my fellow Irelandites. Other important thing to note here is this is a LIM AC DC version. Some of these will just say LIM AC without this underscore DCO here. So you don't want that one. You want the one that says LIM AC DCO. So there's part numbers and stuff on that you can grab there to help you in your search. Prices for these vary. Before the Brexit thing. I think I got this one from the UK for £40 sterling. The 2017 module there was €100 from a local breaker's yard. And you can look around on eBay and places like that. They are plentiful. Brand new from my favorite automaker's parts department. I just checked the price today. Will set you back €278. So not bad, even brand new. So the LIM has got a total of 4 connectors on it. This one here, so second from the left, has got no pins in it. The reason that it has no pins in it is that there's a version of this LIM that's used for Japanese vehicles, and they have the CHAdeMO functions built into the LIM. Pity I didn't know about that back in 2015. So if you had a CHAdeMO version, they would have pins in here, but we have the CCS version. So basically we have the, this is where we connect to our charge socket from this connector here, this connector here, and this connector here are where we put in power, CAN, and various signals. Now for information on what those signals are and what the CAN is and all that good stuff, I have a repo on GitHub, which there will be a link in the description too. And also I'll put a link in the description to the development thread over on the Open Inverter forum. So I'm not going to go into things like what pin does what in particular here. The part numbers for the connectors and so forth are on the forum. And I have asked for folks there to set up a wiki page on this for us as well. So hopefully that'll happen soon. Now, the LIM runs from 12 volts DC, and we give it a 12 volt ground, we give it a 12 volt constant, and we give it a 12 volt wake up. Other things that we connect to the LIM, apart from the charging socket, which we'll get to in a minute, which connects on this guy here. Other things we connect are the CAN bus, which is currently hiding on us, which is just 2 wires. Anyway, this is our CAN here, I think. Yeah, this is our CAN. We have a RGB LED here. It's currently off because the LIM is asleep. So basically it's a common cathode RGB LED. Obviously I'm just using a little 5mm one, but in the car this, you know, it's some much bigger affair that lights up the whole charging port. So, but this is good enough for development purposes. This little guy here is what I want to talk about next. So this little board and these 2 small contactors here, let me go over here a little bit like that. Yeah, so this little board and these 2 contactors are connected to our LIM, because the LIM basically controls both the positive and the negative fast charging contactors separately. So there's 2 wires for each one. So that's what we have here. Now this little guy is quite interesting. I was doing some general research on this a couple of months ago, and was looking at the pinout. And there's a pin on this that looked to be some kind of a feedback signal from the KLE, which is the charger, the normal AC charger in the BMW i3. And I was looking at some diagrams on the BMW Tech Info. And I'm looking at the KLE and I think, hang on a second, I think I have one of those. So I had a look through my junk pile, and indeed I did. So I took that thing apart, and in there I found these 2 contactors and this little board And the board has got two crimp terminals on it here. It was connected on the, I guess, the fast charger side of the contactors. So, chap on the forum that was working on this as well was able to confirm that what this board does is it provides an isolated voltage monitoring between the fast charger side of the high voltage and the LIM. So it has a fully isolated feedback signal that comes in here. This is it here. That goes into our LIM. And basically this lets the LIM measure the DC voltage on the charger side of the contactors. It does some other stuff too. There's some high voltage interlocking and some other thing. It probably, I don't know, talks back to the mothership. There's an STM8 processor on there. So this was fine. And so recently I was doing some investigation here on the bench and I couldn't get this board to work. When I applied 12 volts and grounded the relevant pins, the pin that has the output signal was just basically sitting at 12 volts. It didn't seem to react to anything that I fed in on the isolated side. So a lot of messing about, and eventually found out that it's not a voltage signal that this board produces for the LIM, but rather a current signal. The LIM expects to see very close on exactly 3 milliamps going into that pin to signify 0 volts on the fast charger side of the contactors. So I'm going to have to design something to replace this so that folks can use these for DC fast charging. But that's not a big deal. I can do a bit of reverse engineering on this little guy. But the advantage is for me here, having the exact board means that when it comes to trying out the DC fast charging, this will be one less component that I have to think about. Well, you know, do I have the signal correct or have I screwed up somewhere? So at least we're using the OEM part. Now, speaking of the OEM part, these contactors are the little guys that I pulled out of the KLE. And these are our fast charging contactors. Now, I got a tip off recently. I've no idea now because as to whether this is true or false, but that the LIM looks for the contactor coil resistance as part of its diagnostic procedures. Now, I can confirm that during AC charging, I can have these disconnected. It doesn't make any difference at all whether the contactors are connected or not. That doesn't make any difference to it. Now, again, just to eliminate variables when we're testing, I'm going to have to do a little bit of jiggery pokery because I've already built up my high voltage fast charging contactor box in the E46 using these Gigavac much larger contactors, and I just far prefer these just because they can handle way more power. So what I'll do just to eliminate this as a variable is I'll just temporarily fit these outside of the contactor box and just use those to switch the 12 volt coils to the larger contactors inside our fast charging contactor box. And once we get that working, we can then switch to just direct driving these guys and see if the thing still works. The reason it may not is that these have an internal economizer. So what could be happening is that the LIM could be doing PWM on these contactor coils and economizing them. So if it is, we're going to have to come up with a solution for that, like with a resistor across these or something, just to work that out. But just want to get that little bit of information out there to folks. Now, I have been droning on. My apologies for that. But there's a bit more, unfortunately, that we need to cover off here. So we've got our LIM, we've got our little sensor board, as I call it, and we have our contactors and our RGB LED. So what else do we need? Well, last piece of the hardware puzzle for our LIM is going to be over here. Let me see if I can get you in a little bit better than this. My camera work is as shoddy as always. Wouldn't expect any difference from me, I suppose now. So right in here, right beside this, this thing here, you're going to see this little collection of crocodile clips and a red and a green LED in there. There's a resistor, there's a 1K resistor here and a 10K resistor here. Now there's a little relay in there, and I've connected that relay to the output from the LIM that would normally drive the locking motor on our charging port. Obviously here on the bench, I don't have a locking system for the plug. And personally, I don't use connector locks on any of my vehicles of my own reasons for that, which I'm not really going to get into here. So the LIM, I'm probably going to get this wrong now. The LIM is designed to work with a Phoenix Contact manufactured CCS socket. And there is a data sheet on the forum from that was kindly provided by one of the folks working on this. And that has a lock feedback system, whereby when you are unlocked, it wants to see a 1K of resistance between two wires, and when you are locked, it wants to see 11K. So hence we have here hence we have a 1K here in series with a 10K. Now the 10K is connected across the little relay in here. Now unfortunately, we can't just use a standard relay, like say this one, which just has a coil here and a changeover contact, because this works on the principle that you apply a voltage to the coil, and as long as that voltage is applied, the contacts will flip to the changed position. When you take the voltage away, the contacts flip back. But there is a kind of a relay that is this little guy, which is called a bistable relay. I'll try and get that in here so you can see it, but I'll put the part number for this on the forum anyway. And this guy works, again, it's got a coil. It's got a coil there. You can see the two coil terminals closest to you, and then the changeover, two sets of changeover contacts there. But it works on a different principle. When we apply voltage to the coil, it changes over the contacts. But when we remove the voltage from the coil, the contacts stay in that changed over position until we apply a voltage with the opposite polarity. Then the contacts change back. We can remove that voltage and the contacts will remain in that location, or whatever configuration. Okay, so we need this here because the LIM is designed to drive the little DC motor that's in the Phoenix Contact socket, and that motor is just basically a simple little geared motor with a cam that basically we have a little slot in our plug. So we put the plug in and the motor just drives the pin in, and then that stops us pulling the plug out. Until then, we flip the polarity and the motor pulls the pin out and we can remove the plug. So what I've done here is I basically simulated that here using the bistable relay. Sorry, it's wires in the way here. Using the little bistable relay. And you'll see here when we do a lock and an unlock cycle that the little red LED will flash and the green LED will flash then. These two LEDs are connected across the relay coil, but they have the opposite polarity. So when we're driving current in one direction, only one of the LEDs lights. And then when we drive current in the opposite direction, the other LED lights. So I'll be using something like this in the E46 just to make the LIM happy with the connector locking system. Of course, I would recommend anyone doing this themselves to use a connector lock, but that's not something that I do. So we've our LIM, we've our sensor board, we've our contactors, we've our RGB LED, we've our little connector lock spoofing circuit. Let me pan over here a bit and just up on the vice there. Sorry, the camera, this tripod's all over the place. Just in the vice here, you'll see I've just got a 3D printed charging, just a type 2 charging port. And I have some clip leads here, just connecting to the earth PP and CP pins of that. It's just a simple and quick way for me to have a charging socket. And on the floor there then you'll see just a type 2 granny cable. So that just can put out 10 amps of current, and I've just been using that here for verifying that I've got my charging initiated. So just back over here to the LIM then. So what I've got, let me bring you back here a little bit now. Just got to watch all the wires here. So what I've got sending CAN to the LIM is this little board here. This is just a random board that I designed for something that I never really developed further. But it's got an Atmel SAM3 processor, CAN transceivers, USB and so forth on there. So I use this just for general simple kind of software development, and all it's doing at the minute is it's got a USB connection back to the PC. It's got a CAN low and a CAN high here that's going to our LIM, and there's a super simple little program on there that is sending out CAN to the LIM at the minute here, basically simulating some of the messages that the LIM expects to see. Now on my laptop here behind us, I have a little serial terminal which I'll show you shortly. But before we do that, I'm going to run through just a few charging cycles here with the granny cable, so you can see the thing actually doing something rather than listening to me talking about it. So first thing we'll do is we will bring you over here. I'm going to bring you over here, and you might be able to see both at the same time. Can you? Yes, you can. I'm going to turn off the bench light, but you're going to be looking at the little RGB LED here and the two, the red and the green LEDs on our lock faking relay. So let me turn off the bench light so you'll see those a little bit better. Now at the minute, our LIM is in what I call manual mode. So it's basically waiting for us to plug in. But when we plug in, it's not going to go ahead and do anything. until we tell it to do so. So I'm going to get my Type 2 plug, stick it in there. So the first thing observe I should say, is that our little RGB LED has came on a kind of an orange colour. Both the red and the green are on there. Now I'm going to send it the begin charging command from the computer. I want you folks to watch our RGB LED and our little lock indicator. So press C and press enter. So basically what happened there was, you will have seen that we locked the cable into the charging port. So we got, I think it was the green LED that flashed there. And over here we've our blue kind of pulsing LED here, which is telling us that we're charging away merrily. And down there, I'll just show you on the floor, you can see the flashing green LED on our granny cable that is plugged into the into our little socket there. We can come back over here. Now if I go ahead and end the charge, just do that, just press D. So you'll see that we unlocked, the red LED flashed, and we're now back to our kind of orangey coloured LED here. So I can go ahead and unplug. Now the next kind of it's just a very simple little thing we can pick up when the plug has been inserted. So if I turn on automatic mode here on the computer, auto charge active. So I'm going to go ahead now, and just as if we were plugging in the car just to charge it, I'm going to plug this in. We'll see the connector lock and the charge mode come up. So we're locked, flashing blue, and there's our granny cable back on there. So this is our AC charging working away. I'll bring you folks over to the computer here and just let you see the little serial terminal readout. So super simple little Arduino DUI program basically in there that just lets us send commands there, like I can switch off the charge by pressing D, and it'll basically shut us off. It reads out the pilot current, which is 10 amps, the cable limit 13 amps. We see that the plug is inserted. The control pilot status is just standard AC control pilot, auto charging deactivated. So I can just press C and it'll basically go through its little charging setup again. So then CP status tells us that we're charging active. So that's my little Arduino sketch for running the AC side of the LIM. This sketch is up on the GitHub repo as well for those of you that want to play along at home. But Damien, I hear you all cry. We're not here for boring AC. Show us some DC action. Well, obviously not having a CCS fast charger here means I can only get so far, but okay, I'll get as far as I can and show you that part. So, number one thing that we need to do is tell our LIM that we have inserted a CCS plug. We do that by means of the coding resistor. Don't know what the coding resistor value should be, so I went to my local CCS charging station with a multimeter and measured it. It's 1.5 kilo ohms for those of you who might want to know such things. So I've got two 3K resistors here in series, signifying that. So now we have told the LIM that we've plugged into a CCS charging station. Now we need to tell the LIM that we would like to initiate the horrible green PHY power line communication crap. In order to do that, we need to supply it on its control pilot pin here a 5% PWM signal. So in order to do that, got my trusty Keysight. Oh, there's some dodgy camera work. Got my trusty Keysight scope and signal generator combo here, and a 1K resistor in series to signify a charging station. And we go up here. We look at our scope screen. Let's see, do we have, hopefully you'll be able to see it anyway, 5% PWM duty cycle. Now, over here on my little Arduino sketch, we have detected that we have a 5% DC control pilot and that we have a plug inserted. In case you don't believe me, here it is here. So plug inserted and 5% DC. Now, the bad news for the rest of this video is that despite my best efforts, it might end up turning into a funny cat video thanks to the arrival of the GOM cat. For those of you that might be interested, the GOM cat was a neighbour's cat. They moved away, abandoned him, and he then took over my workshop and my chair and my shop coat. Yeah, so say hello to the internet, GOM cat. Right, that's that part done. So now, where do we go next for our DC adventure here on the bench with the LIM? Well, I haven't quite worked out the necessary CAN commands as yet to get the LIM to attempt the power line communication crap and to time out for it in our little Arduino sketch. But the good news is I have a CAN log from a DC fast charging event. So I'm going to disconnect the Arduino and we're going to throw that CAN log at the LIM now in a few seconds, and we'll see some interesting LED activity, so stand by. Alrighty, so SavvyCAN is punched up and ready to throw some DC charging request frames at our LIM. While we do have the cable coding resistor correct, we do have the 5% PWM correct, that's where things are going to stop, because we're not obviously going to be able to generate the green PHY crap, and we're not going to be able to put high voltage on our little board here to do the contactor test and all that crap. But still do something a little bit semi-interesting. So, and go. Or not. Possibly not. Oh, well, we're definitely sending frames. Yeah, we're definitely sending them. So I think I've annoyed it. Yeah, I think I've annoyed it because it's taken me too long. Yeah, okay. Let's stop and we'll go again. Take two. Okay. Aha, there it is. Success finally. So you'll see that we've got a nice pulsing red LED there. I had to just sequence my what's the name of it? Control pilot signal a little bit. So we've got a red LED now because we're not doing the green PHY comms. So it's basically after unlocking the plug now, and is basically just going to time out, and it's going to go into a kind of a crazy loop here once we go back around the CAN. But the interesting thing is that we can get it to that point where it is looking to do something. So let me just pause this here for a minute. I want to load another filter file that I had, because we've got two filter files for the DC side of things. One hasn't got as many messages nearly as the other one, so I just want to see if it does the same thing again for me. Might as well test it on your dime. So basically that is as far as we can go. Obviously it's not going to do things like energizing the contactors and that, unfortunately, here on the bench without seeing some of that green phi action on there. So that's about it for the demo phase. Oh yeah, there it goes. So there's our red LED there now. That's with the second filter file for our DC CAN messages. I hope you folks have enjoyed this one. Definitely a bit long and super boring, but there was a lot of ground to cover. So as I said earlier in the video, my next move here, let me stop sending some CAN to this thing. My next move here is to install our 2017 LIM into the E46 Touring, and actually see then if we can get some DC fast charging going. I do have some info on managed to find some of the IDs on there for controlling the current. So hopefully I won't have any problems with that. I am going to use one of the 50 kilowatt stations just for the initial testing, because fun though it would be to screw up somewhere and ask the Ionity station for 1000 volts at 250 amps. They'd need a vacuum cleaner rather than a body bag for me if that happened. So we won't do that, hopefully. So that's about it for our current LIM extravaganza. If you do have any info on the LIM CAN and are willing to share that with me, then please do get in touch and let me know. But other than that, we'll just keep plugging away at it. There's a DBC, there's a CAN DBC file up on the repo as well that I'm constantly adding to as I kind of figure out various messages. So with a bit of luck, that'll be useful for people working on the i3 and even a more general sense than just the LIM and the whole DC fast charging stuff. So all right folks, I've gone on for way too long here. I'm going to wrap this up. Thank you very much for tuning in. Thank you for all the support, particularly the people that have helped recently with trying to get these i3 CAN logs. We've been 6 months trying to make that happen. So big thank you and thumbs up to the folks that assisted me with that. Because in just a few days now we've gone from 0 to what you see here. Just again as a gentle reminder, this is a fully open source project. There won't be any paywalls or restrictions on this. Again, assuming it gets working, I'll code this into the VCU, so it'll hopefully be a kind of a all-in-one charge port controller system. If you like what I'm doing, do consider supporting me on Patreon or PayPal or any other way. It is very much appreciated. So that's it. I'll stop there. As always, dislike. Do not share this garbage. Unsubscribe if you have for some reason found yourself subscribed. And until next time, happy LIM hacking.